me to be here virtually with you today. I know this is the last talk before lunch, so I'm going to make it short and sweet. I know that this is the hardest one of the day. So like Crystal said, my name is Tatiana. I'm a groundwater geologist with the Nebraska DEE, and I've been with the agency since August of 2019. And like she said, I manage the wellhead protection program and the source water protection programs for the state. So essentially, my job is to help communities protect their groundwater from contamination by working collaboratively with all the stakeholders involved, from the local level on up to the federal level. And I would argue that everyone is a stakeholder when it comes to water. So natural resource resiliency is something I'm very passionate about. So I'm very grateful to be back in my home state working in this field. So with that, we're going to move down from the rhizosphere that you guys have been in with Dr. Clapperton all morning into my realm of focus, and that is the saturated zone. So I'm sure most of you are aware of most or all of these, but even if you know Nebraska water inside and out, here are a few little refreshers. So Nebraska is a groundwater state, as I'm sure you know, with 88% of our residents drinking groundwater. And if we take out Omaha and the Omaha metro area, which gets about a third of its water from the Missouri River, that number goes up to about 99% of people in our state drinking groundwater. So essentially all of the rural residents of the state use groundwater for our domestic supply. And as you know, our irrigation wells also pull from groundwater aquifers. So the map on the right shows the active registered wells in the state, and you can see the large majority of wells are these green these green irrigation wells, and then the domestic wells are followed by blue that are kind of underlain by that. So one thing to note is that the domestic wells weren't required to be registered prior to 1993. So thousands of domestic wells exist that are not necessarily shown on this map. But even with these unregistered domestic wells, irrigation definitely takes the cake for water use in our state, as you can see. So this data is from the Quality Assessed Agrochemical Contaminant Database, which is a repository of groundwater data from many different sources across the state, and it's provided for public access by the Department of Natural Resources. So prior to the database, monitoring was performed by many different organizations for their specific needs. So for example, the NRDs were looking at nitrates and ag chemicals because they have some authority over them, whereas the public water systems were monitoring for a large number of pollutants that could potentially pose health risks. So to address the issue of having all of these different organizations submitting samples, the Department of Ag, UNL, and DEE began the agrochemical database in 1996. So what happens is UNL staff examine the methodology of each of the samples, and then they rank them for confidence so that users can analyze the data based on the quality of the samples. And then after the samples are ranked, the data is posted on DNR's website at the link shown here. So you are more than welcome to go there and check out the data if you're interested. So the table on the left over here shows some of the partnering organizations who submit samples to the database, and the one in the center shows some of the compounds that are more commonly found in the Nebraska wells. And then over here are the types of wells that are sampled and submitted to the database. And then if you look over here in the middle, so the number of samples that exceed the reporting limit. So the reporting limit is the concentration that a lab can validate their analysis. So for example, if a contaminant is at a level below the reporting limit, it can't be detected by the lab and it's just labeled as a non-detect. So the majority of samples show that groundwater in Nebraska is of very high quality, as many of you know. However, the samples also show that several contaminants continuously show up in certain areas of the state at high concentrations. And they include nitrate nitrogen, which is a form of nitrate common in human and animal waste, plant residue, and of course, commercial fertilizers. Atrazine, allichlor, and metallochlor, which, as many of you know, are herbicides used for weed control, especially on corn and sorghum. And other compounds with notable detection are the degradation products or metabolites of atrazine and allichlor. So namely D-ethylatrazine, D-isopropylatrazine, and ethane sulfonic acid. So we know that the elevated levels of nitrate and herbicides in our groundwater has been associated with the practice of irrigated agriculture, especially corn production. And in an effort to address this, the NRDs implement groundwater management areas based on the groundwater sampling data, and they recognize that non-point source groundwater contamination is an issue in our state. So what are the health issues? So nitrate is an acute contaminant, which means one exposure can affect a person's health. It reduces the ability of red blood cells to carry oxygen, which can cause methemoglobinemia, also known as blue baby syndrome. And when a baby's red blood cells can't carry enough oxygen, they can develop a serious health condition where their skin tone actually turns blue. And other links have been made between nitrates and certain cancers, thyroid disease, and also birth defects. So the map on the left shows incidence rates for pediatric cancer across the country. And as you can see here in the middle, Nebraska has some of the highest incidence rates in the US. And then the map on the right, which I think is really interesting, shows watersheds with higher incidence rates. So I'm sure you can pick out the Turkey Creek watershed down here, the area up in the Brazil, where the Elkhorn River is. And so these are areas that we well know across our state as being high in nitrates. So this year, UNL received a $5 million grant to start the Water, Climate, and Health program based at UNMC. And this is a tremendous opportunity because it will bring together experts from the Institute of Agriculture and Natural Resources, from the Dougherty Water for Food Global Institute, and many others to research the links between water contaminants, climate change, and also health impacts. So why are we seeing pockets of high concentrations of nitrate? Well, as many of you probably know, two major things play into the vulnerability of an aquifer, which for us is how contaminants get into our drinking water. So the first is the depth of the water table, and the second is the permeability of the soil. So if our water source is near the surface and we have sandy soil combined with heavy nitrogen application and irrigation or rainfall, contaminants can move freely past the root zone and into our groundwater. And this goes back to what Dr. Clapperton was saying about different plant species changing the soil aggregate, essentially changing the permeability of the soil and increasing infiltration. So this map shows aquifer vulnerability across the state using depth to groundwater and soil types. So you can see the places with the highest vulnerability are in sandy soils and along rivers and streams, in places where the water table is relatively shallow. But it's much more complicated than just water depth and soil types. So the geologic history of Nebraska is actually very dynamic and complex, as opposed to what we see on the surface, making it really hard to actually understand how water and contaminants are moving once they get past the root zone. So to talk about water quality in our state, we really need to talk about how our aquifers came to be. And to do this, we're going to trace back to the sediments that shaped the Nebraska subsurface back millions of years, to the Cretaceous period. So this paleogeographic map shows the North American continent about 75 million years ago. And then during the 200 million years leading up to this time, the climate warmed and cooled, and as ice formed and melted, the sea level fluctuated in response to that. In addition to the ice melting, volcanic activity was also occurring in the mid-oceanic rift zones, building continents and displacing seawater. So during the late Cretaceous, the global climate was much, much warmer, with average temperatures of the ocean being up to 95 degrees Fahrenheit. Carbon dioxide levels in the atmosphere rose to over 1,000 parts per million, and the poles were completely devoid of ice at this time. So these seaways are really important because they're the source of a lot of the sands and gravels that make up some of the best aquifers around the world. And generally, as we know, sand and gravel have a high permeability relative to things like silt and clay. So even more recently, during the Pleistocene, Nebraska was subject to several periods of glacial activity. So when glaciers advance, they rip up rocks from the land around them and beneath them, and they act just like a big conveyor belt that just tears everything up jumbles it up and then spits it out when it recedes. And this deposit is called glacial till. So the green line here shows the extent of the glacial margin that covered the eastern part of the state. And you can see, I should have outlined Nebraska, but you can see our state right there. So when the climate begins warming and glaciers start to melt and recede, rivers start to form, and they form on top, below, and within the glacier of running meltwater. And so rivers are really great at sorting sediments they transport, and they can leave little pockets of well-sorted materials within glacial deposits, which serve as what we call pocket aquifers. So to take a little bit of a look of a profile of our state, this is an idealized cross-section, so it's very generalized, but it shows the different aquifer materials. So on the east, we have the tills from the glacial activity overlaying the sandstone from the seaways. And in the west, we have more sands capped by what we're really familiar with in our state, which is loess. And notice that all of these deposits have different characteristics on a granular scale. So here, looking at the till, you can see that it's poorly sorted due to that conveyor belt action from the glacier. And there are tiny grains that can fill in the pore space between the grains, between the larger grains, making it a lower permeability deposit. As opposed to up here on the left-hand corner, we have well-sorted grains deposited by water, which have large pore spaces and yield a higher permeability. So the rising seas deposited sands, silts, and clays along the coasts and in river valleys. And these deposits are known as the Dakota Group, which I'm sure some of you might recognize as the common bedrock unit across parts of our state, and sometimes a viable aquifer in Nebraska. So the Dakota is part of a greater system of aquifers known as the Great Plains Aquifer System, which underlies most of our state. And very few wells are screened in the upper Big Blue in the Dakota, as the water quality is pretty marginal. As you can see here in the middle, this is a map from UNL's Conservation and Survey Division. So the Dakota in the middle part of the state is pretty low quality, and that's due to mainly total dissolved solids being pretty high in salinity. And then over here, you can see the glacial margin where you have good water quality, and you're most likely screened in some of those pocket aquifers. So this is the most widely used and best known aquifer in the state, and many people refer to it as the Ogallala Aquifer, but it's actually a system of aquifers of different ages all stacked up on top of each other. Technically, it's called the High Plains Aquifer System. And the Ogallala Group is actually the principal geologic unit of this aquifer under Mosser, Nebraska. And I'm just telling you this nuanced information so that you can be that annoying person who corrects people when they say Ogallala Aquifer, and they're not referring to the specific unit. So these Pleistocene deposits cover most of the state and are where most of the wells, especially in the upper Big Blue, are screened. And the High Plains Aquifer is mostly made up of layers of sand, gravel, and sandstone with smaller packages of silt and siltstone and clay sprinkled in. And it's a lot thicker in the sand hills than any other part of the state. So this is a map that I find really interesting. It just shows the major drainages of Nebraska with the glacial extent and the Cedar Bluffs till, which is a deposit, which is a glacial deposit. And you can see that the Big Blue River is controlled by the extent of this Cedar Bluffs till. So this line right here is the till, and this right here is the glacial margin. So it's really amazing to me how much this historical geology affects our drainages today. So here's a map of the High Plains Aquifer System showing the saturated thicknesses. So the High Plains Aquifer spans across 8 different states, and as you can see, Nebraska sits over the bulk of it, with the most saturated thickness up here in the sand hills, between, I think, 600 and 1,000 feet of saturated thickness, thinning out as we go east. And the map on the bottom right, down here, is from USGS, and it's the modeled vulnerability of shallow wells to nitrate across the country. So you can see the faint outline of the High Plains Aquifer down the center, and unfortunately, you can see these massive swaths of high vulnerability areas in our state. You can make out even the Platte River Valley here and the Elkhorn, and then if you look really hard, I'm not sure how well you can see it, but the upper big blue is this yellow splotch right down here. So in my opinion, this isn't the kind of thing that we want to be known for across the country. So circling back to this question, we know that many factors contribute to the high concentration areas of nitrate in our state. And the areas that are most impacted are the areas that are most vulnerable due to these conditions, depth to water and permeability. So this is a map of the most recent nitrate concentration data in the state, and it was published in the 2020 Groundwater Quality Monitoring Report that DE just submitted to the legislator like 2 weeks ago. So we just finished this report. So you notice the common theme of the nitrate concentrations that mirror the highly vulnerable areas that we could see from the national USGS map down here. Here's the upper big blue, and then up here in the Brazil area. So most of the upper big blue NRD is at or above the 5 milligrams per liter level, with a number of townships that are at the 10 to 15, which is, I think, this orange. So yellow is the 5 to 7.5, and then the orange is 10 to 15, which once you reach that 10 to 15 MCL level, well, the 10 is the maximum contaminant level for health. So once you reach 10, it warrants a notice of violation from the Department of Health and Human Services. So what happens is once a public water system gets a notice of violation, they have to act pretty quickly. For example, within 24 hours of receiving the notice, they have to post a warning in public places, and then they have to hand deliver the notice to all customers. And they also have to provide an alternate water source, such as bottled water or filtered water, to infants, pregnant women, and nursing moms. So this obviously isn't sustainable for communities to do repeatedly, especially if they have high nitrates. So what can they do? Well, there aren't many options for treating nitrate in water, but communities could still site a new well, pipe into another community and buy water from them, or they could build a treatment facility to remove the nitrate using something like reverse osmosis or ion exchange. And I'm sure some of you are familiar with the RO plant in Seward or the aquifer storage project in Hastings that pumps high nitrate water from the top of the aquifer. So what they're doing is in Hastings is the high nitrate water is pumped out of the upper aquifer, treated by a reverse osmosis system, and then pumped back into the aquifer to improve the water quality and bring the level of nitrates down to below that 10 threshold. And then also some of the high nitrate water is then pumped into a storage lagoon, and it's held there, and it can be either sent to a nearby farmer's center pivot or to a wastewater treatment facility. So dealing with nitrate isn't cheap, no matter which route you go. So the cost of many of these projects dips well into the millions. So for example, Hastings project is about a $46 million project. Seward's facility was $4.3 million. I know York has had to shut off high nitrate wells and drill others. McCook's ion exchange facility plus 2 new wells, a pump station cost the city, I think, over $10 million. So ultimately, all of these very expensive projects do not reduce the amount of nitrate in the groundwater for the long term. They're reactive measures and they are not sustainable indefinitely. So what can we do? So the good news is that we're headed in the right direction. We know that improving our soil health in Nebraska is the most effective way to address many things in our state, including flood mitigation, groundwater contamination, improving crop and forage productivity, and especially profitability. So increasing infiltration, building soil organic matter, and all of the great things Dr. Clapperton is talking about in today's workshop are things that folks are doing, but we absolutely need more people on board. It's also really hopeful to me to see that the Nebraska legislature has prioritized soil health with the passing of LB 243. This was in April of last year, and this bill led to the creation of the Healthy Soils Task Force, which is made up of 17 members who are ag producers, educators, policymakers, environmental reps, and agribusiness folks. So I don't know if any of you have heard of the term a wicked problem. It's kind of a buzzword going around right now, but it's a problem that's so complex and multifaceted that it may not be solvable. And I've been on several conferences recently that a lot of folks are calling the nitrate issue in our country a wicked problem that's ultimately maybe not solvable. But personally, I'd like to think of it more as a wicked opportunity. I think we have a huge opportunity to revolutionize the way we farm in Nebraska through collaboration of all stakeholders. And as I said at the beginning, I think we know that we're all stakeholders when it comes to water. We all rely on water for our livelihoods. So I'm hopeful because the amount of collaboration around this issue, especially at the local levels, gives me hope that we can turn this thing around, maybe even in my lifetime. So thanks to all of you for being here, because you are the major part of that. So here's my contact info. I'm at the DEE in Lincoln, and if you have questions about wellhead protection, source water protection, water quality, local geology, anything, feel free to shoot me an email or give me a call. And if I don't know the answer to your question, as I'm still pretty new in the agency, I'll definitely find the person who does and get you the information that you need. So with that, I will stop sharing and send it back over to Crystal.
Do you have time for a few questions?
Yeah, absolutely.
I saw there was one on the chat. What do you think is the timeline to see a change in farming practices and to see a change in the aquifer's nitrate levels? I mean, that's kind of a tricky question.
Yeah, no, that's a really good question. And I think, it really varies when you're talking about, I'll speak to the change in aquifer nitrate levels, but I think that when you're talking about seeing the fluctuation and seeing the reaction, that's what makes it such a difficult, wicked problem. So a lot of times, yes, we're dealing with nitrate that is being applied now, but a lot of it, as you know, is legacy nitrate. So some of this nitrate that leaches below the Brit zone and is moving into our groundwater is hung up in the vadose zone, which is the unsaturated zone between the roots and the saturated zone. So what happens in the vadose zone is kind of mysterious. We don't fully understand yet how contaminants move. And that's something that is being tackled by the university right now. But in some places it could be just a few years, and in some places it could be decades. But as far as the timeline to see a change in farming practices, I think that answer is probably better known by the folks in the room than me.
Do you have any other questions here in the room? Do you have any questions from our Zoom audience? I think I have made it so you can unmute, but feel free to use the chat if we're not able to hear you. Or let me know via the chat if we can't hear you.
Yeah, and I guess, sorry, just to jump back on that question too, there are definite success stories around Nebraska, especially like in Hastings and in the Central Platte Valley, where folks are seeing results from applying, things like cover crops or doing no-till practices. So it really just depends on how dynamic your subsurface is and what the vulnerability of your aquifer is. So if you have an unconfined aquifer that is easily recharged, you're going to see results a lot faster than if you are screened in a deeper aquifer that is maybe confined. So